Okay, Assalamualaikum and good evening. So we'll continue today with the chapter 3, subchapter 2, which is setting up a sustainable energy management system. Okay, but before we start, would like to have I would like to brief you on a few announcements. The first being that your test one will be on uh, the lecture session, which is on this Wednesday morning. So all the question has been prepared and it will be distributed via Google Classroom. And I'll assign the timer to make sure that you be getting it by 8 o'clock sharp. So please do check your Google Classroom when you got into the class. And if I'm not mistaken, the time to answer is 1.5 hours. I'll make an announcement or I'll make a post the exact apa nama time frame later on in the Google Classroom. But typically, you'll have 30 questions in all. Sorry, 20 question of multiple choices A, B, C, and D. You just double tick on that. You just tick on that, whichever the answer that you seems necessary, you find correct. And then part B, you'll have a subjective answer on which you need to uh, scan or whatever method that you find necessary lah for you to apa nama print out the answer in PDF form and submit it via PDF forms. Again, so for subjective questions, you need to answer it. Each question will have a upload link within that Google Classroom punya Google form. Basically what you'll be doing is you will go into your Google Classroom, and from there you'll be assigned a Google form that you can click and answer your questions lah. And for the subjective part, you'll need to submit the answer that you have written or typed, but you have to submit it in PDF forms. Regardless if you're using PowerPoint ke, your sketches using your own ni ke, so you have to scan and then convert it into PDF forms and then submit it via the link provided in under that question for subjective answers. Sorry, for subjective questions. Okay, all the links will be in the same Google Forms, so make sure ni lah submit via that link lah. Because the reason why I would like you to submit it via there rather than Google Classroom is because apa nama all the answer will be categorized or cataloged within that link rather than Google Classroom pun boleh sebenarnya, but Google Classroom and then ada pula Google Form might as well. If you feel like if you feel unsecure, then yes, you can submit via Google Classroom and Google Form. But typically, if you submitted via Google Form, should be enough lah. Okay, and then second announcement, I have checked the attendance in UFuture. Apparently, I think some of you either haven't gone into the class or might have attended class but forgot to click on the future attendance list. So make sure, I just like to remind you guys, make sure to click your future attendance list at the start of the class so that you don't forget. Because just in case that's the case, because for those who didn't attend and have given me the proper justification, no issue lah, inshallah. But for those who have no justification over their in attendance, so they maybe, because you have to remember you have 80% attendance punya record, only then you will be able to be considered as, I mean, if there is no issue with your tests and your project, then okay lah. But if there is an issue, that means test 1 fail, test 2 fail, punya project pun cukup makan je. Then if I found out that your attendance is less than 80%, I have no qualm to fail you. So make sure attendance, make sure you guys every single time logging into the class, make sure to tick on the future link first. It's just a matter of tick. But of course, I do note that some might forget, but since it's already passed and it's already in the system, so I don't even know how to modify the attendance list, given that it's passed. And of course, I don't have any record of you whether you attend or not physically. So just keep in mind moving forward to double check and always tick on your attendance in your future, just in case you are the case of forgotten you have forgotten to tick it previously. Okay, so in summary, two announcement. One, test one will be in Wednesday. So the Wednesday there's no class, but you still need to tick your attendance in your future, just for the sake of safekeeping. I think if you have submitted via Google Form, shouldn't be an issue. But itulah, just to be safe, just once you logged in to your Google Classroom, also make sure you tick on the your future link for your attendance. Any question before we proceed with the class? No, eh? Everyone okay? All right. Okay, so as usual, I would like everyone to turn on their camera for record because every class is recorded. So make sure to turn on your camera to make sure that everyone is in the class and not doing something else. So, okay, one, two, three. Make sure to turn on your camera. Few of you have turned on, but most still haven't turned on the camera. Okay, most of you have turned on their cameras, so rather than waiting for others to turn on, I guess we can start so that we can end our class quite early because this topic is actually even though it's theoretical, but uh, there will come a part where you will be using this as a tool for your mini project, which involves maybe using your Excel program, or maybe if you fluent with, but typically student will use Excel to set up the baseline for your company's energy. Okay, so that's it. I will be going through the theoretical part today, but the example and showing it how to calculate, I guess I'll continue after mid semester break so that you won't forget how to do it. But for today, we'll be focusing more on the theoretical part, which is that covers setting up sustainable energy management system. So when the first thing, of course, after you've been appointed as energy manager, after you've completed and get the commitment from the top management, basically you've set up the energy policy for the company. The next step, when it involves the actual baseline that you need to set up for the case study, is to set up the energy accounting centers. So energy accounting centers ni, as we go along, I'll be calling it EAC, energy accounting centers. So why do we need energy accounting centers? Is because we are trying to measure the energy, because we want to give a number to energy that has been consumed for the interested part for that organization. It can be the whole organization. It can just be a certain part that you're focusing on mainly. So it's quite difficult to control and manage if you're only looking at the TNB electricity bill. So macro level, basically what it meant is if you have a company which is sizable company yang besar, and maybe lah tak payah cerita panjang, just look at apa nama Petronas Kertih tu. If you look there, there's tons of, I mean, it covers quite a acre. I mean, the meters quite the acre, the acre, apa, the length, the width, the dimension of the area for that Petronas, what do you call that? Penapisan processing plant. Yeah, the Petronas processing plant there. If you go there, you notice it's quite long, it's quite huge. The area. So for you to observe only on the electricity bill for the whole Petronas area, chances are you will not be able to identify which area needs to be saved, which area can go as business as per usual, which area that needs to cut down on their operating punya parameters. So macro level, there are two. One is macro, then the other one is micro. Micro, like microscope. If you recall, microscope, you're looking into very specific area. But for macro, what it meant is macroeconomics, the general economy of the theoretical part of the nation of the country or whatever lah. So macro is the whole area as a whole basically. So it's quite difficult for you to identify and control which plant or which area that needs to cut down versus going into micro. So but typically when we are talking about macro and micro in energy management, of course in measuring the energy being consumed, macro is the TNB bill that you receive monthly. That is macro. You imagine in your house when you receive electricity bill, it doesn't mention okay fridge pakai berapa, microwave pakai berapa elektrik, TV pakai berapa elektrik. Tak ada kan? Dia terus bagi pump sedepuk satu biji rumah tu. Okay, this amount of energy multiply with the rate of the government tarif tu, and then you get your electricity bill monthly. The one that we have discussed lah in chapter 1. Even though itu sebenarnya chapter 2, tapi saya dah terdiscuss on chapter 1. So that's macro. That means you don't know exact area which is actually the one that consume the most out of your monthly electricity bill. So that is why we need EAC. EAC basically we break it down from the monthly electricity bill tu. Kita break it down to smaller chunk so that we can identify which area yang we need to focus more compared to the other. So that is what it meant why when it asks us why we need EAC. Okay. Oh yeah, I forgot. Test 1 will cover chapter 1, chapter 2. So that covers how to sekali apa nama tu? Covers energy pricing and also energy audit. So try have a look lah. Okay, so to effectively control energy consumption in the organization, we should then, as energy manager, divide it over small parts, which we call as EAC or Energy Accounting Center. So number of EAC will depend on the size and the condition of each organization. So the bigger your organization, there will be, the bigger the organization, there will be a lot more EACs lah as compared to a small company. But that doesn't mean it's true. It depends juga if there's a lot of process going on in the organization, even though the size and the scale is smaller compared to maybe Petronas, macam kita tengok Petronas besar kan. So if the company has a machinery itself pun boleh juga jadi one EAC. So it depends. So it does not fall under all circumstances that bigger company will need bigger EAC. Doesn't mean that if the company is bigger but it's just an airport, that means no point lah awak set up EAC banyak-banyak. Most probably one or two should be enough sebab airport kan. But if you're talking about maybe manufacturing punya building, even though tak besar, it's just one factory, but each department to have their own energy consumption that you need to tap. So that means the EAC as compared to airport tadi will be much more lah compared to airport and also building yang besar-besar sebab dia melibatkan proses manufacturing. So it depends on the size and also the condition of organization. And EAC should be provided with adequate metering equipment. So this is the keyword here, the metering equipment. There's no way for you to measure your electricity or your energy. If you're talking about, we are talking about electrical energy. If you're talking about what do you call that, water energy from water, then you have to put a flow meter lah, most probably. But for electrical energy, typically because electrical is the one that we use to power up all our lightings, all our aircon, all our machine. So that is why the stock is more on electrical machinery, electrical power. So there is no EAC, there is no energy management if you don't have metering equipment installed for that area ke machinery ke any kind of things that you want to call as EAC, you need to have metering. So that means you need to install instead of solely depending on TNB meter that is located outside of the building that generalize the whole electrical energy consumption being used. You need now to install specific electrical energy meter lah, basically electrical meter at each EAC punya yang the one that you have defined lah. So that you'll be able to see and calculate the exact actual energy being consumed for that particular machine, for that particular area, or for that particular EACs. Okay, so that means you need to have budget in order for you to conduct electrical. Once you have, in order for you to effectively conduct an energy management system in your organization, you need to have budget. Ni nak tak nak kena ada lah. This is setting up EAC, setting up the baseline of the energy memang tak nak the company have to fork out their own money. Ini memang tak di-covered by any kind of energy service providers or energy efficient energy management company, energy efficient management, yang company yang provide the contract yang kita ada cakap minggu lepas. Saya lupa apa nama company. EAC. So there are actually some budgets that you can gain from them, but typically before you can call them in, you need to have your own budget. And then each AAC that you have defined should have their own EEI or Energy Efficiency Index, which we'll elaborate later. The target and the plan that you want to achieve throughout the year for that particular EAC, the budget allocated for that area or machinery or what EAC that you have defined, and also the monitoring process to make sure that the auditing process or whatever is being implemented as per intended lah. Okay, I received some WhatsApp message, but never mind. Okay, so how do you define EACs? This is critical, especially for your end of the semester mini project. You need to make sure that you define EACs correctly. So in order for you to do that, to effectively call the EAC to define the EAC for your organization that you're proposing is correct, you have to have the data. So for your mini project, again, you have to get the data, or either that, or after discussing with my colleague, maybe we'll provide to you, depending on UiTM punya pentadbiran ni, whether they okay or not, kita akan kongsi data tu dengan korang. But if not, then nak tak nak korang kena Google lah. But most probably will, but we on our end will try our best to get the data for you. And you have to study that data first. Only then you'll be able to define the EAC. So what does this mean? That means you need to install the meter first before you're able to say, okay, this is the EAC that I want to call it EAC1 or this is EAC2. So you have to have the data first. So that means you have to install the meter first. And also that means you have to get the budget from your bosses before you're able to define your EACs. Now that means, again, you have to get their commitment. And then basically data in regards to the energy consumption lah for area that, of course, you need to have some sort of apa nama understanding. You tak boleh lah setiap laluan meter tu you nak tap mahal lah nanti apa meter data log yang you nak measure tu, you nak beli tu. Kalau boleh tap yang dekat main source before that area masuk lah. So of course for business most probably business student most probably tak tahu. So nak tak nak ni memang kena discuss with your engineers or anyone who has technical expertise in electrical energy consumption lah dekat your company. So ni you can work with the energy management committee dulu. And then once you have installed that, make sure you got the monthly energy consumption, you got the amount of, so not only the energy coming in, you have to also measure the amount of production being produced as a result of the energy being supplied, because you're going to need that data for calculation, either area or process, but you need that data. The amount ke, product being produced ke, the weight ke, nantilah kita tengok lepas ni ada dia punya what kind of parameters that you can use as to measure the output. And then output generate from each equipment, such as ton of cooling generated by chiller. So if you can't measure the output, for example chiller, you know that chiller, typically chiller memang electrical energy dia memang banyak lah. If you have maybe yang for those yang maybe well off sikit, they may have chiller box yang buka macam apa nama, kalau kita pergi kedai tu buka and dalam tu ada ais-ais semua tu. So that chiller box typically will consume significantly your electricity bill. So you can't exactly measure the dimension ke, dia punya cooling apa ke, apa dia punya product being produced ke, tak boleh sebab chiller. So what you can do is measure the cooling ton of cooling generate ni maksudnya in terms of degree Celsius per operating hours ke apa. I think after this ada kot dia punya assumption for chiller and also temperature punya ni, but typically for those type of equipment you may not have a product coming out, so you can't measure the output. So what you should do is measure the intended purposes, which is to cool down the area. So you need to measure the area and also the cooling that it's achieved as it operates throughout the month, which I think we can look at after this other table here. So this is an example of an office area, maybe kilang for example. This is the main gate. So you can, of course, this is orang kata not as very efficient lah. As you can see, production line 1, production line 2 is their own EAC. So you might need to have a lot of data logger installed. So at least 1, 2, 3, 4, 5, 6, 7, 8 data logger. And you have to know data logger typically will cost around a few thousands. So having 8 it will be close to 100,000. I think your boss wouldn't like that. Okay, data logger, you can't buy the cheap one, because data logger needs to be very especially in factory environment, they need to be very rigid, rugged. Tak boleh karat, tak boleh, at the very least they has that IP65 ratings and also explosion punya material yang dia boleh tahan. That one typically will cost a few thousand mahal. Because you want to measure the energy for years, not just month, not just days. So you need to buy the most expensive one. So if you're defining your EAC quite detailed like this one, most probably your boss wouldn't approve your energy management program. Okay, so but this is basically the most beginner punya mistakes lah if they define the EAC. But basically, what it's trying to show is that this area can also be defined as EACs. Like if your boss has significant funding for the project, then chances are you will be able to do it like this. And this is more accurate lah. Defining your EACs like this. So as you can see, EAC defined here for front office is the data that you can record is the working hour per day, which is 8 to 5, for example. And then you can use data like monthly electrical consumption data. But this is for front office lah. So front office is here typically will only involve air condition, lighting, and also condition lighting at the most yang consume significant electrical consumption. So that's why you need the data working hour as the output, monthly electrical consumption data as the input. That means you give a certain amount electrical energy so that worker can work the hours indicated in their contracts. Typically, at the most 10 hours. Okay. And then warehouse is also the same. You need to get the energy consumption versus the warehouse working hours. And the others ni boleh baca lah. But for raw material is where's the raw material? Raw material basically you wouldn't measure the raw material weighing in, but you need it as input for the production line EAC. If you indicate that production line 3, for example, here as your EAC, so raw material will be the input lah, that you need to measure so that you'll be able to define your EAC correctly. Okay, so this is basically just an example of what data that you can record specifically for each area. Doesn't mean that this EAC is correct, but because for me, this is quite expensive. If you define it like this, for me, I would like to put warehouse, front office, and canteen as one EAC. So you only need 1 meter. Production line 1, line 2, and line 3, okay, fine. But utilities and wastewater treatment, utilities, you need to have their own because they have chiller and boiler here. But wastewater treatment, okay lah, boleh lah, one under EIC. But 1, 2, 3, actually for warehouse, front office, and canteen, if it's me, I will put this together as one EAC rather than separately 3 like this. But the example that they are trying to show to you is the data that you could define lah as the EAC's data for you to calculate the baseline energy being consumed for the organization. So these are the data that you could use. So how to define the EACs? Should define the EACs based on first and foremost, you need to have the data. So if the EAC that you want to define does not have data logger, no point of you declaring it as your EAC. Because all these EACs, you need to use the data to submit a report to Suruhanjaya Tenaga. So if you're declaring it as EAC, but you don't have any data backing it up to show that in the end you're able to save energy, you just claim it, or I'm able to save this energy based on my electricity bill, which typically Suruhanjaya Tenaga will not accept. You need to make sure that they already, the area that you need to define as EAC has a rate data. That means you have to already install the meter in that equipment or building, and only then will that area be applicable to be considered as EAC. It can be area, it can be equipment, and also it can be the whole system, maybe cooling system, HVAC. So HVAC is connected to maybe front office, warehouse, canteen, and also functional areas possibly. So this is also this 1, 2, 3, 4. These 4 area can also be considered as EAC for the process of cooling process. Depends. Okay, but first and foremost, you must have data, existing data, not upcoming data, existing data. That means it has already happened. You got the data, then only then you'll define that as your EAC reading. Sorry. Okay, but you can, like example is being shown here, you can dedicate one EAC for one building. It depends on your needs and also your budget. Like this, warehouse is one EAC. So administrative building, warehouse is one EAC, production plant second EAC, third is the second plant, and then administrative building for one is EAC one. You can also put it under a system, which in this case, steam generation and distribution system, because steam may involve, let's say, for example, where's steam? I can't see it here, but supposedly maybe this lah, this area here, utilities. So steam from boiler can be used to connect production line 2, and also production line 3. So even though there are different sets of production line, but since they are using the same steam steam generation system, so production line 1, production line 2, and production line 3 can be compiled together as EAC 1 example, because the same steam is being used for the whole process. So that means it comes from the same sources. That means the output is also from the same sources. You can measure that heating per area punya calculation, the same lah for the production line 1, production line 2, and production line 3. And then as the data, you can lump sum it under EAC for that particular system lah. For area, for example, is you define production line 1 is the one whole area as one EAC. For equipment, you can go down directly to the, let's say, for example, maybe chiller 1 as your number 1 EAC, chiller 2 as EAC 2, boiler 1, boiler 2 pun boleh sebenarnya. Tapi again, it depends on your budget, your company objective. Maybe they found out after doing the general measurement, they found out that only this area need to be focused. So that means you need to install each equipment here their own meter. So equipment punya installation meter will be much cheaper lah daripada the whole area, because I mean, and then it will be much more easier because you just have to shut it down and then plug in whatever cable coming into them that power them up, and then plug a meter there over there, then it should be okay. But for areas, sometimes you need to do field study first to determine where the sources coming in, and then properly make sure everyone shut down the areas punya consumption electrical energy, which is can be hard, especially in production during production month. So yeah. But basically, you can set up EAC based on area, equipment, or a system. So in this case, this is a system, but you can also make it a functional, a combination of which, let's say, for example, wastewater treatment and system. Sorry, what's the difference between this wastewater treatment? I think it's the same. This area here is almost the same as this one, but so, but basically, I think this one is the same as this one. It's just that this one area where it uses system to decide that as EAC2, because wastewater treatment system is just one whole area. So I don't see the difference between this one and this one. Am I right? Oh yeah, combination. Sorry. This one focus only on the equipment, boiler house only. So boiler house, I assume this area lah. Instead of the whole utilities area, they only use boiler house, so they don't consider chiller 1 and chiller 2 as something that they need to save, for example. So again, there's no right or wrong in determining the EACs, except if your budget was this amount, let's say maybe 100,000, but you only want to measure, but you're proposing to your boss only to measure boiler area only. That means, sorry, your budget is only 10,000 and you want to measure the whole area. That means you're in the wrong lah, because the budget only allows you maybe to be specific, but you want to measure, and then you propose to your boss, you need to install the meter over here, and canteen, and then you, I mean, not realistic to the objective that the client wants you to do. So that means that one is wrong. Okay, in this example, the same. So I'm not sure why it is being reshared again. So I guess we can just skip it. Oh, okay. So for this example, they define production line 1 as EAC1, production line 2 as EAC2, production line 3 as EAC3, and the whole area under cooling system as EAC3, and heating area as heating equipment as EAC4, and then specific. So I'm not quite sure why. Okay, and then EAC5 as the wastewater treatment, and then the whole office building, which involve canteen, front office, and warehouse as EAC5. So based on their electrical measurement and data monitoring, they found out that for administrative building, which is warehouse, front office, and canteen, can be considered as one whole EAC because their electrical energy consumption isn't as significant as production line 1, line 2, and also the other EACs. So typically the one in the red apa namanya box ni, the grouping ni, typically will not be as huge lah. So they can maybe instead of installing apa nama focusing more on this area to install solar energy ke apa ke, they might as well focus more on the one that significantly impact the electricity bill, which is EAC yang production dan juga boiler chiller utilities ni lah. So it's much more effective for them after they have conduct the initial study. Maybe this one is just kalau tak ada orang kat office, tutup aircon, tutup office, tutup switch, amalkan tu je. Okay, fine. Whereby this one, you need to install for this EAC, you need to install apa? A much better cooling element kat chiller ni ke, for example. So because the punya electrical energy consumption is significant. Okay. Okay, then once you have set up the EAC, once you have got the data from the meter, what do you need to do with the data? Yeah, so basically, if you recall, I keep on mentioning baseline, baseline, baseline. So this is basically the baseline, the data yang kita define as baseline, which is the energy metric yang sebelum ni. And then this one is EEI. Once you got the data, you can set up energy efficiency index. So basically, this is the KPI lah, yang every year you have to measure to make sure the energy saving that you implemented, all the method that you have implemented actually membuahkan hasil. Ni lah EEI ni lah. Every year kena buat audit, kena make sure EEI menurun. So basically the definition of EEI is to measure the efficiency of the energy being used for that particular process. So the calculation is energy input, the energy amount of energy being used divided over the panggilnya factor related to energy using component. But I think the easy way to understand it is how or what is the output that once the energy been given to the system or the machine. So what is the output of that? So input over output. Okay, energy input over the output related to the energy being given here. So the output that we can measure to divide over the electrical energy yang kita dah measure mula-mula every month tu. So is the what you can do if is the process of production, you can measure the weight, number of item as a result of the energy being given, the weight of the raw materials being used, and also other parts lah, period of production, plant usage, floor area. So it can be anything. Especially yang ni bab ni memang nak tak nak you have to refer those who are fluent with the system, with the process, or the engineer ke whoever, or somebody who's designed the machine, because you need to be able to measure correctly. There's no point of you measuring susah-susah measure this parameter, end up rupanya parameter tak ada effect pun dekat energy that you supply. Chances are benda yang measure tu typically benda lain, dah buang masa dah. So might as well you get direct to the point, the source, which is the one who knows about the process, and these are the items lah. One you can use they suggested lah, but of course you need to refer the person who are actually very fluent with the process themselves to make sure that you didn't measure the wrong parameters. So for example lah, yang this one kilang senang nak tengok, but let's say lah, I think hospital pun dah banyak implement energy management back in 2014 and whatnot. So hospital, there are no product, there are no apa nama input in terms of electrical input tu electrical input lah, but there's no product being produced. There's no apa nama items being produced. But what you can do, of course, bila electrical energy being used in a particular ward, for example, when there's a patient, right? So when there's a patient in that particular bed, typically you will need to turn on the light, turn on the aircon to make sure the patient felt so basically only when the patient comes in will the room be lightened up or will the electrical energy being used. So that's why you can also use the data of inpatient as the output that you need to divide by the energy being supplied lah. So this one memang kena faham lah proses tu. So if hospital, typically in bed patient, staff working, how many staff are working for the area, for example, because when the staff working, chances are they need to turn on the lampu, even though dia tak lalu pun kawasan tu. Tapi when there's a emergency ke apa ke, they need to lah lari-lari pergi ke patient tu kan. So electrical energy kena on lah all the time sepanjang dia ada. Okay, but macam ni hotel, you can also measure occupied room, meaning tak logik lah kalau apa tak ada tenant tiba-tiba aircon tu hotel terbantu lah so marah lah hantu tu nanti panggil bomoh ke. Okay, and then the definition of EI, the factor which most accurately reflects a practical application of the energy. That means macam hospital tadi, apa yang logik when for the electrical energy to be used. Again, the patient coming in, that if there is a patient. Tapi kalau ada hantu pun, typically dia hantu takkan buka aircon, hantu takkan buka lampu. Tak seram lah kalau hantu buka lampu. I don't know lah kalau tengok Ju-on semua tu dia buka je lampu, tapi typically in logic hantu tak buka lampu. Manusia ada dalam bilik baru dia buka lampu. So the energy being used tu you have to the factor that you choose as the tadi kan rumus tadi EEI over electrical apa factor related to energy being used has to be logical. It must reflect the practical application of the energy that you are trying to measure. I mean the energy that you have been given for the input. So, so that the best measurement of energy performance need to be selected. Once the unit EEI has been selected, organization has to set up the baseline for selected EEI, which will be the base energy efficiency of the organization. So EEI ini basically, as you can see, one formula nak senang faham. It will be a positive number. Sorry, the bigger the number, that means the less efficient the energy being used. Why? Imagine 10 divide over 2. So you're given 10 energy, but the factor as a result of the energy being given is only 2. That means 5. The EEI is 5. That means the number is big. So that means it's not efficient. Compared to, let's say 10 divide over maybe 8. So 0 point something something. So that means this is more efficient. So my conclusion is that for EEI, the bigger the number, the less efficient the process is or the area is or the system is. The lower the number, the more, if possible, negative lah, but tipu lah negative kan. Typically, the lower the number, the more it is closer to 0, the more efficient the process is. So the objective here is to get EEI as the years goes by, to get the EEI to the lowest numbers possible. Okay. Yang ni tak ada apa je as definition. Just that they highlight, you have to make sure the factor that you've chosen reflects practically the process being used so that it's accurate. Okay, then there are 3 steps that you need to do to perform in order for you to set up the EEI baseline. First, nak data collection lah. You can't divide something, you can't multiply something, you can't plus something if there's no number. Of course, in research, there are this thing called qualitative and quantitative. But in energy management, nak memang quantitative. There's no point of view EEI, energy input kilowatt hours, for example, 100 kilowatt divided over bagus. Macam mana you nak divide? Tak boleh lah. 100 kilowatt hours divide over memuaskan. Tak boleh lah nak divide. Kena ada numbers. So, to get the numbers, you have to collect the data. So, that's the first step, which is installing data logger lah. Nak dapatkan numbers tu, you have to install data logger for that particular equipment or particular area or EAC tadi tu lah. And then once you got the data, you need to establish the relationship between energy input and the factors using the energy. So let's say, for example, you're giving 100 kilowatt hours for this machine, to produce a certain amount of product, let's say gummy bears. So 100 kilowatt hours tu, kena make sure once you have implement energy management, the gummy bears produced tu makin lama increase. Or at the very least, kalau same pun, energy input tu makin lama berkurang. Again, a bigger number divided over smaller number, you'll get bigger numbers kan. Yang EEI tadi. So again, bigger number EEI, that means kurang efficient. So your objective here is either to get the input to be smaller, EEI ni tadi, rumus ni, energy input to be smaller, or the factor which is gummy bears tadi tu, bigger, lagi banyak. So depends on you lah, how do you want to do it, but this is how you report your baseline improving or not to the ST or to your top management. Okay. Okay, once you have that number, you will be able to, once you got the relationship tu, basically you'll be using Y equals to MX plus C lah. Seboleh-bolehnya kita akan menggunakan linear relationship, sebab apa nak accurate sangat pun nanti pening kepala pula nak kira. So typically people will use linear relationship, which is Y equal MX plus C. You know, the rumus yang straight line tu, kalau kita buat graph tu, approximation. So typically we'll use YMX plus C lah. Kita tak akan pakai quadratic, kita tak akan pakai apa nama yang kalkulasi kita belajar yang sampai kuasa 5, kuasa 7 tak pakai. Sebab nak memudahkan kerja. So Y equals to there, okay, for me lah, who have experience trying to find out relationship between parameters. There are only certain things in life that uses more than Y equals to MX plus C. Non-linear relationship maksudnya. Non-linear relationship ni, that means kalau saya tolak awak, doesn't mean awak akan jatuh. Macam sekarang ni, kalau saya tolak awak, typically awak akan jatuh lah sebab saya lelaki, awak perempuan lah. If you're talking about perempuan. Unless memang perempuan tu apa yang MMA punya fighter ke, then most probably dia lah pukul saya. But typically, normal human being, kalau saya tolak awak, chances are awak jatuh. But there of course only certain limited application where non-linear relationship occur. So that's why for setting up baseline EEI, cukup saya merepek tadi tu, typically you will only be using Y equals to MX plus C, and trust me, if you are pursuing energy management in the future, chances are agak tinggi lah sekarang ni government nak introduce carbon tax tu. That means you need to be more familiar with Y equals to MX plus C rather than equation yang susah-susah. So make sure you brush up lah. If let's say one day you work with energy management. Okay, so first we look into the first step, which is data collection. There are 2 types of data, which is energy consumption data, and also what you need is the output. Yang you need to measure to quantify the input being given versus how much output is being produced, which is in these terms is called factors related to energy being used. So for energy consumption data, you can get it from energy bills, the TNB bills every month dapat, or also plant records, production records, operating records, and also existing meter and submeters. If you don't have meters, then your job will be much more harder because you have to come up with a proposal to buy this meter to your boss, and typical boss. Kalau tengok kena beli benda baru ni seboleh-bolehnya dia tak nak lah. So you have to make a strong case, especially now that your boss has been served under Regulation 16 yang kita belajar sebelum ni, ingat. And also now that the government are planning to introduce carbon tax, you have to make a case for that lah, for them to buy you as an energy manager a new multimeter, bukan buy siap pasang semua. A new energy measurement meter, typically we call electrical meter je lah, multimeter ke apa, data logger lah basically, install dekat area that you want to define as EACs. Okay, so if possible, get existing meter data first. Chances are, once apa nama, for small company there will be not an issue lah, because you can use the TNB bill. But depends how varies from cases to cases. But if possible, try to use existing meter first before proposing a new meter to be installed. Okay, and then for consumption data, it can be in terms of kilowatt, which is defined as maximum demand. If you look at your TNB bill, there ada tulis maximum demand. Basically, unit dia kilowatt. Energy consumption per period, so that means you have to get the per hour, which is kilowatt hour. The unit will be kilowatt hour then. Okay, reactive power. This one is more, kita akan belajar most probably at the end. I'm not sure the new syllabus, but previously I did explore a bit on KVA and PF. But I think for business, you will not go into detail this area here, because maybe I'm wrong, because if I'm not mistaken, in chapter 4, yeah, you'll need to manipulate the maximum demand, and in order for you to do to manipulate maximum demand, you need to know KVAR and PF. Don't worry, it's just multiplication. But how to multiply, where to multiply to yang maybe a bit hard, and I'll try my best to explain KVAR and PF. Basically, KVAR is the phase. Typically in Malaysia, we have 3 phase transmitted to your house. So KVAR is the phase that you want to measure, and PF is the power factor to make sure the voltage and current is almost in the same waveform, so that you don't receive voltage dulu tapi electrical lambat sangat nak dapat. So tapi nanti saya elaborate lagi lah. No. And then you need to measure the electricity rate, dollar per kilowatt being produced, being used, and other specific charges which may differ country by country. Okay, and also fuel rate and actual consumption depends on the type of fuel. Fuel rate ni, if you're using gasoline and minyak yang biasa kita nampak in oil market lah. But if not, then you have to refer the market value for the fuel that your machine is using. Okay, so these are the recommended unit if you're using if you're trying to measure the machine input for, if you, let's say you define your EAC as that particular machine. So you need to, because this calculation here is under the assumption that I've just discussed to you just now, is energy input was more on electricity. But you have to remember, if you define your EAC as just, let's say for example, this boiler only, boiler 1 and boiler 2, they won't, boiler typically will not be using only electricity. They will also use fuel because they need to heat up. If they are using electricity, mahal lah nanti. And not only that, it's not efficient. So they need to, in order for you to efficiently burn fuel, you need to have an efficient fuel, which is either RON 90 berapa lah, terpulang lah, how the process, what the process needed. So let's say you're using RON 95. So, and on top of that, you're using electrical energy. So that means you also need to factor in fuel as the energy input being used for that particular machinery. So for fuel, typically we are talking about liters. Even if you fill up your tank, your car ke, your motorbike, you're actually measuring it in liter. If you tak percaya, pergilah pump station, tengok dia akan yang bergerak tu, ringgit per liter if I'm not mistaken, bila kita tekan pump kan. So yang kita tengok of course ringgit lah kan, tapi actually bawah dia tu ada liter. So typically when we are measuring liquid, it can be oil, it can be fuel, it can be whatever gas pun sebenarnya boleh dalam bentuk liquid juga. Is measured in liter. Except for okay natural gas and also LPG, whereby kalau yang physical form macam ni liquid, kalau coal and lignite, I'm not sure. I haven't had a chance to explore or interface with lignite, but coal typically is something like kayu, coal, karang. So it will be measured in ton lah. But for gases, dia lain sikit. LPG, liquid minyak yang dah di liquid, sorry, gas yang dah di liquid kan. Basically still fuel, but it's liquefied gases. Then it will be in kilogram, and because dia punya liquid itu kalau nak measure direct susah. So typically it will be in kilogram. But and for gases, MMBTU. British, if I can't recall, is that maybe after this they have some definition, but you can Google it, MMBTU, but it's British ton unit. I can't recall what it meant, but the BTU is British ton unit. Okay, so if let's say your machine uses diesel and also natural gas, how can you use the same, because it's a different unit, you have to remember, if you want to calculate this energy input, you can't put a different unit over there, then it will be bunch up lah. Pening lah nak solve kan. Of course, try to imagine you're measuring liquid, you put the energy input as liquid, air, and then letak sebelah batu. How are you going to quantify that? Tak boleh. Sebab dua-dua ni unit dia berbeza, atom dia berbeza. Okay, so that's why you need this joule energy as a result of using, let's say, for example, diesel. So this liter of diesel, let's say 1 liter of diesel, actually translate to 36.42 megajoule of energy as a result of using 1 liter of diesel. So this is basically the conversion factors that you need to use if, let's say, your equipment using a different set of fuel, kerosene, and then dia pakai pula coal, for example, ini ton, ini liter. So how are you going to measure to samakan dia? Guna conversion factor ni lah. So conversion factor ni basically is the amount of energy yang scientists have proven, bukan baru nak test, proven and accepted worldwide of as a result of 1 unit of that liter ke tan ke of benda yang kita nak measure tu, fuel tu, based on that fuel. So from this table, it shows that for charcoal, which is coal, coal sama lah tu. Based on 1 liter of charcoal, 1 ton of charcoal, you should get 28.88 megajoule per kilogram. And you have to remember this is in kilogram, so you have to convert ton ini kepada kilogram dulu, and only then you'll be able to multiply with 28.88 ni, so that the unit will be in joule. So that later on, when you want to use this formula, EI unit input, you can just plus. So kalau sini tan, sini liter, awak tak boleh plus. Ni physics I know business may yelah nampak nombor tambah je apa kira kan. No, for physics lain unit, that means lain physics property dia. Awak tak boleh tambah batu dengan air. The same concept kat sini lah. Tambah batu dengan air memang nampak macam together, tapi it's not efficient lah your presentation. Tapi lah, itu physics class. But just remember, kena observe unit. So make sure in your proposal, in your mini project, let's say your data gives you 2 energy input, jangan simply tambah just because awak nampak dia nombor sama. The unit will be different. So macam saya cakap, batu tak boleh tambah dengan air. Kalau tambah jadi benda lain. Kita nak batu tu batu, tambah air tu air. So tak nak dia jadi lumpur ke apa ke, tak nak. I hope my explanation tu cover lah. Tapi basically you can't simply plus data because the unit may be different. That means apa ni, your EI will be wrong. And if let's say you found out that your equipment uses a different type of fuel, that means if you want to use it, you want to calculate the energy input, you have to convert using this table dulu, conversion factors. Of course, you can Google also. In case your input tu tak ada listed here, I think you can just Google conversion factors or type of fuel. I think you can get the answers for different types of fuel energy. Okay, and then to determine the factor related to the energy use, because previously it's just energy consumption data, the input. Now you're trying to get the output. So must be relevant to the collection of energy consumption. Basically, again, in a highlight untuk factors, if you decide, you must make sure that it's practically viable as a result of the energy being provided for the equipment or the process. So dia tak ada elaborate sangat, but sepatutnya for me, again macam saya cakap gummy bears tadi tu, make sure electricity kalau supply, make sure kalau sebelum ni 5, either you're reduce the 100 kilowatt hours kepada 80 kilowatt hours, producing the same 5 amount of gummy bears, or 100 kilowatt hours of energy being consumed, but gummy bears jadi 8. Then yes, your energy management program can be deemed as good by Suruhanjaya Tenaga. So make sure the output that you're trying to measure must be relevant to the energy being used. So there's no point awak measure, let's say for example 100 kilowatt hours, the product produced is gummy bears, tapi awak measure dia punya conveyor belt punya movement. Tak tepat lah, sebab anything can be on top of that conveyor. It's not maybe not gummy bears. It can be just gummy bears yang tak jadi instead of gummy bears yang jadi. Especially in bab makanan ni adalah macam cake. Out of 100, biasalah if your phone pun sebenarnya out of 1,000 or 1,000, dia ada rule dia actually in manufacturing. Out of 1 million, maybe percentage of failure will have 1 unit yang fail. So itulah saya dah elaborate lebih sabar. Next. So how are you going to set up your baseline based on EI calculated? You can use it versus time, which is monthly basis ke yearly basis ke, up to you. Typically people will use monthly lah at the very least. And then once energy management has been set up, you'll need in yearly basis lah. But you can also set it up versus production and operation, and then production and operation versus energy consumption. Tadi EEI, ni EEI versus time, EEI versus production. You can also, to make sure lagi detail, nak present kat ST dengan your boss, you can also use energy consumption. That means, let's say lah, for example, you don't want to interfere with the production of the gummy bears. So you nak maintain 5, tak nak lebih-lebih. Memang demand nak 5 je, 5 gummy bears je every month. So you can show the energy management program bagus in the sense that energy consumption every month menurun, even though produce the same 5 gummy bears, but now the energy consumption makin lama trend dia makin menurun. That means your energy efficiency program tip top. So these are the tools, G1, G2, and G3 that you can use. So this is an example versus time. Maybe this is month, first month sampai 12th month. And then this is the EI calculated for that particular month. As you can see, in the month of March and August, is the highest EI. That means again, you have to remember, the bigger the EI number, the more inefficient the process is. So that means during the third month and the month of March and August, okay, if we maybe time tu mesin kena maintenance ke sepatutnya tapi dia tak buat, or dia terlambat maintain ke, so gears tu terpaksa memerlukan electrical energy yang banyak baru dia boleh menghasilkan, producekan benda yang sama. So that means electrical energy waktu tu terpaksa bagi lebih sebab tak buat maintenance. So bila dah buat maintenance tengok turun, and then tiba-tiba naik balik, shoot balik, sebab rupa-rupanya maintenance tu tahan sekejap je. Gear memang minyak hitam itu tahan sekejap je, So nak tak nak kena tukar balik. And then bila dah tukar, dia turun balik. So you can, that's an example lah. This is an example why it can contribute like that. So from here you can see that this data that you have plotted here after you calculated the EI for that month, you'll know that okay, you have to anticipate servicing, maintenance bulan 2 lagi. Make sure bulan 2 and bulan 7 ni dah buat maintenance. So that dia tak overshoot this EI yang the highest EI ni. If possible, bring it down to maybe 260 area ni because of the maintenance lah. So jangan miss out maintenance. Okay, that is just one example. Kenapa you guys need to plot EI versus time. It's easier for you to see what may cause. Of course, this will be upon discussion juga lah dengan committee. But from here, you see that now you can attack March dengan August specifically to make sure that your energy consumption reduce lah. Okay, this is example of versus time. You can also use it, okay, and then elaborate to understand the nature of energy based on seasons. Maybe musim panas, musim sejuk, dia punya gear berat sikit lah. Kalau musim panas, besi mengembang. Besi mengembang sebab dia serap haba tu. So, musim panas sepatutnya bulan 6, bulan 7 lah, if I'm not mistaken. So, time tu efficient. Tapi bulan 8, dah nak start sejuk ke, for example, before dia implement, dia masukkan minyak, apa nama, dia masukkan, what you call that? Anti-defrosting punya minyak tu. Bila dah sejuk tu, autumn tu, dia gear tu dah berat, dah ngecut. Macam mana? Kembang kecut. Yalah. Besi, the material has shrunken because of the loss of heat. Ni physics lah. So it will be not efficient until the engineer masukkan anti-defrosting. And then once they put defrosting, then now it's more efficient. So that's why you see in the month of September, October, November and December, bagus. Okay, I'm assuming the process may ada machine need apa nama, defrosting, for example. Depends lah. Ni season kita tak merasa, saya pun tak pernah bekerja with machinery during off season or four seasons punya country, so I don't know. But there are certain machinery will be affected. Of course, kalau kita tengok train kereta api pun sama. Actually, nowadays LRT, MRT dah pakai levitation, magnetic, so may not be as relevant lah. Tapi if you went to negara yang four seasons, if I'm not mistaken, yang pakai India, still pakai the steam train tu. So if they went to Kashmir, an area yang mountains tu, boleh nampak lah kot effect besi mengembang mengecut ni. But I can't tell you much because I'm not a railway engineer, so I might be off there. But besi mengembang mengecut ni memang physics tak boleh tipu. Our dimension memang physics ni applicable. So based on that versus time though, we can also determine where the best performance and lowest performance is occurring. So from this data again, March dan April ni lah paling teruk dia punya ni sebab EI dia tinggi. And then if 24-month data can be obtained, you can also use it to compare year to year. So macam ni, only 1 year. So let's say you have more than 24 months data, then you can be able to see what effect this year had to this process as compared to energy being consumed. So then you'll be able to know what factors affecting the energy consumption for that organization. Okay. Okay, then we can also look based on production and also operation. So for production ton of 31,000, it shows that the EI is the highest. That means if possible, try not produce 31,000 because at that time, even though the same energy is being used throughout the production amount here, this is the most inefficient usage of energy input at 31,000 production. So if possible, discuss with your boss to make sure that the production is around 33, 34. And if kalau production demand tinggi, then shoot for 35, 36. But normally try to achieve around 34,000. I think the best for normal every year punya, every month punya operation. Try to achieve 34,000. That means sales kena kejar lah. So that energy input tak apa, maksudnya awak sedut banyak tapi kerja tidur je mesin tu. Maknanya produce tak banyak. And bila produce tak banyak, makan banyak, gemuk lah, bazir lah. So from this production or operation punya plot ni, you can tell your boss, try to hit production ton 34,000 above. That means this is the most efficient of energy being used. If possible, 35 lah, sebab it seems that this is the lowest amount of EI observed. So try to achieve 35,000 per month when your operation. Okay, so that's how you define the data. So it helps to monitor energy efficiency at each production level. So like I said, bila dah tahu ni, janganlah pergi biarkannya, bagi tahu bos, okay, based on this data I've collected, it shows that every month we need to achieve 35,000. Make sure the machine is operating at 35,000. But of course, discuss dengan engineer. Chances are they won't like this lah. Sebab 35,000 ni typically the machine will work hard. That means maintenance pun kena buat cepat. And that means machine tu mungkin cepat rosak lah. So maybe they want you to lower it down, maybe 34,000. Again, there's orang kata people underestimate the simplicity in life. Tak bekerja keras. Nampak macam malas. Tapi in life, it's about marathon. It's not about sprinting. So this is sprinting. So in some cases, if you buy the most expensive machine, most probably boleh handle lah. But again, depend on the machine itself. If you want the machine to run a marathon instead of sprinting because you want it to last longer, don't push 35,000, push 34,000, for example. Make sure it's around 33 or 34,000. Then the machine, you can strike a balance between working hard and also having a quality of life for the machine. That means you don't have to do maintenance that much. You don't have to shut it down so much for, checking or for whatever example lah. While also be profitable. So again, cerita dia bukan grey, bukan black and white. That doesn't mean if you get EI lowest, that means the perfect case for you. No, it may depends on cases. It may depends on the company, the requirement of the company. So make sure check with your energy committee yang ada engineer presence in that committee lah. Okay. Indicates how EI reduce as fixed energy costs are spread. That means kat sini, this assumption here is that the energy being used is constant throughout these production values. That means in 31,000, it also uses 100 kilowatt hours. 35,000 pun menggunakan 100 kilowatt hours. Then this valid lah. This data is valid. The higher the EI, the more energy being consumed. That means tak bagus lah, tak efficient lah. If the energy being consumed more, that means you have to pay more for electricity bills or the fuel purchasing bills. Okay, then you can also use energy consumption versus production or operation. So that means you're using directly the weight of the liter, for example, the liter of fuel versus the operation or the production being. So as you can see here, there's a relationship that you can plot, which indicate, of course, you can't control, you can actually indirectly versus, which is via maintenance of the machine and whatnot. But you will be able to understand the relationship between how much fuel being used, being put into the car, for example, versus the traveling distance the car covered. So you can be able, so let's say that month you only has limited budget to buy this fuel. Once you know this equation, you'll be able to stretch out the best kind of production that you can get for that particular month. So it is important for you to know this so that it elucidates more on the process so that you guys understand, you guys can measure whether the machine is operating at full efficiency or there's some maintenance need to be done. So how to plot it, which is use Y equals mx plus C. EMP plus C ni energy equals to production multiply with pemala, constant, plus sorry, M is variable, it can be the production unit M, plus C the constant. So the straight line represent estimated energy consumption at each production level, so that the relation is Y equals to mx plus C. M is defined as slope of the line, which implies the variable energy, and C represents the fixed energy. Typically during process, that means nak start machine tu, kalau kita sentiasa on off, typically once macam aircon lah, kalau perasan mula-mula awak turn on your aircon, bilik tak terus sejuk, the temperature will slowly go down, baru sejuk kan. Daripada panas tu, slowly bila aircon tu dah run a few times, which is at that time typically is the most electrical energy being consumed waktu start up tu. Just so you know, the smarter way to cool a room isn't just aircon. Actually, if you turn on the fan before you turn on the aircon and let the fan run maybe 10 minutes while the aircon cool the room, you will notice your electricity bill will be much cheaper at the end of the month if you practice that. That means sebelum buka aircon, buka kipas dulu, make sure kipas berjalan, tekan aircon. That is much more energy efficient as compared to awak tekan aircon terus maybe 16 degree Celsius. Itu paling worst lah. Or awak tekan aircon saja at 26 degree Celsius. Actually, turning on kipas dengan aircon at the start of the operation is much more better, because you have to imagine waktu mula-mula nak aircon nak coolkan the room, the motor kipas tu kena cepat pusing sebab dia nak keluarkan haba daripada bilik dalam kepada keluar rumah. So energy required is much more higher lah, whereby kalau it is being assisted by kipas, that means kipas tolong keluarkan sekali cepat-cepat dalam bilik tu, haba panas keluar melalui aircon. So the aircon punya motor tu tak perlu bekerja keras sangat sebab dia ada assistance. Two person solving one problem, the problem will be solved macam cat rumah lah. Dua orang cat rumah, lagi cepat hasil rumah tu dicat compared to one person cat rumah. The same thing goes with cooling a room. Ni tips pro tips for your daily life. If you have aircon in your room, kalau nak cepat sejuk and tak nak bil api mahal, buka kipas dulu, buka aircon. And then after 10 minutes tutup lagi kipas. Kalau rasa nak lagi sebab dah bilik dah sejuk kan, bolehlah biar aircon dia. Okay. So back to the slide. Basically C ni is the one energy being used during startup. Ini memang nak tak nak machine memang akan ada. Any kind of machine will have a startup process before it become saturated, so that the process continuously lah. So and then M is the variable energy or the energy efficiency that being implemented lah. So as you can see here, the higher the slope is, the higher, macam mana nak cakap slope ni higher, cerun tu lagi cerun, that means your efficiency isn't as good lah. Kalau lagi dia flat, almost flat, then efficiency tu bagus lah, because that means at this 10,000 production, M let's say lah, the punya difference isn't as big compared to this. M memang besar, so that means at 60,000 M dia tinggi value, that means your efficiency isn't as good lah. And if you able to get it almost per plateau, straight line, horizontal, vertical, that means the efficiency throughout 10,000 production ke 20,000 production ke doesn't matter. That means the efficiency is the same. So that means your efficiency is good lah. So the steeper the M value, the steeper the M, the higher the values are of the M, that means inefficient lah, the process. Okay, so I actually hope I'm able to show the example here, but since of course you guys have test tomorrow, Wednesday, I might as well wait for the example to be discussed on after midsummer. But basically, this is the type of data that you can expect lah for your mini project. You need to have this kind of data across. It can be years, it can be month like this. Depends on what you want to try to achieve. So here you can see this is the output, the production being produced, and this is the energy unit that you need to divide over. So that means here 1000 divide over 101 production, you'll be able to get the EEI, right? So double check on that because EEI here shows 265. Oh, sorry. This is in megawatt. This is in liter. This is MMBTU. So it uses three different source of fuel or electrical energy input. So three different. So that means you have to convert these numbers here to megajoule. So you have to use this number. Okay, but that means 1,098 multiply with 3,600, and then 4.73 thousand liters multiply with 36,000. And then once all this fuel has been converted into megajoule, only then you'll be using it to an as EEI equals energy input, the one that you have converted divided over the production pieces 100 or 110 background. Then actually this number makes sense. And you can also distribute accordingly. For electrical, just use ni bagi 1 million divided over 1001. And thermal, which is diesel, and I'm not sure, natural gas, sorry, natural gas, plus make sure convert to MJ first, plus, and then divide over production. Okay, and then once you got the data for January, continue for February until December, put it into Excel, plot it, and then you can use the Excel function to approximate the best linear approximation. And I'll guess in the next step, I guess you will be doing this in hands-on using Excel to find out Y, which is the approximation, and also the R squared. R squared ni dia punya accuracy of the data, which I'll explain later. But basically, this is the data that you will get from the internet, and then to set up the baseline for your company for that first year, and use Excel to plot the relationship, and then and this will be your baseline for the first year. The y equals to 0.258x ni equation ni basically kotak ni is actually your baseline for that year. So next year buat lagi sekali, collect data ni, and then plot the same data, make sure y ni seboleh-bolehnya makin vertical lah. That means your efficiency is much better because m is almost flat. And then you'll be able to claim that energy management program that you have introduced is applicable, is good, and then maybe review accordingly. Okay. So this one, there is no fixed rule in setting up the baseline EEI, but most organizations will set average as baseline and lowest as saving target. So this one nanti kita tengok example. And EAC and EI ni just explanation tadi, example of ni lah, what kind of recorded data. So EI here for front office, warehouse and canteen is the working hour. For pre-processing, raw material. For chiller and whatnot is the fuel being used to start the process and whatnot. Okay, so this one I guess will be focusing more on after mid semester so that you guys can focus and tak lupa lah nanti. Hopefully tak lupa. Kalau saya ajar sekarang nanti kalau kabut nak prepare test one lagi apa lagi. So I don't prefer that lah. Okay, any questions so far? Maybe regarding your test that you want to ask me, or maybe subject. Any questions? No? Okay, if there's none, then I guess we'll end our session today. with Tasbeki Farah and Surawal As. Test nanti ada soalan kira-kira tak, sir? No. Chapter 1, Chapter 2 tak ada kira-kira. Try look at your notes. You'll notice at the most pun flowchart lah. Tu hint saya kat flowchart. Tak ada kira-kira, so don't worry. Just understand the regulation punya process tu. And also apa lagi ya, chapter 1, chapter 2 I think. So that means even though saya cakap energy audit ada, energy pricing ada, that means no kira-kira. So faham-faham lah. Okay, ada question lain? Tak ada. Okay. So thank you for your time. Hope you have the rest of the day boleh prepare for your test. And if there's any question again, you can ask me in the group or in the WhatsApp group, WhatsApp personally lah. Okay, thank you all. Have a great day. Welcome, welcome. Welcome all. Have a great day. Stay safe. Make sure. Apparently kat UiTM dah ada student kena COVID. So make sure you guys stay safe.